This content is brought to you by BEC Financial Technologies, developing and operating IT for Danish banks.
Please warmly welcome Patryk.
Thank you. Hi guys, welcome. My name is Patryk, as she just said, Mierzejewski. I'm a development manager and a system owner in BEC Financial Technologies, but this is now. My whole journey started as a Java developer. Then I was a consultant, architect, up to the program director, rolling out data centers and building the networks for NATO. And now with my colleagues, I'm helping BEC to support the Danish banks. So today I'm going to have a pleasure of showing you how 60 years old fintech is going through the tech transformation. What is our idea behind it and how we want to achieve this, and how Java plays a vital role in all of this and how to make this happen. So let's start. Before we're going to go into the details, I just want to tell you a little bit about us so that you can understand the history, the environment, and the challenges which we have or what sort of situation which we are in. Because Danish banking sector is far different than anything else. It's not like in Poland, in Europe, or so. In Denmark, there are literally no international banks. They are only Danish banks. There are hundreds of banks in Denmark, from the big ones to the medium ones to the very small ones. And by the small ones, I mean 4 or 5 employees. How cool is that, right? A bank with 4 employees only. So back in the 60s, more and more regulations came in, more demand, and those small banks decided that they have a common goals, they have to meet their common requirements, but they are not able to focus and fulfill everything like marketing, law, solutions, etc. And they came up to this sort of idea to form cooperants. And this is how BEC at that time was formed in 1964 as a central that is supposed to support the various banks with the bank reference solution. And ever since, initially it were different solutions done as times were passing by, IT solutions were kick in. And over the last 60 years, we are supporting the Danish banks in this respect. So what it means is that if somebody would like to open a bank in Denmark, they literally would just need an office, a desk, 2 chairs, internet, and a laptop. Everything else we as a company can supply, from the mobile app, online banking, to all the backend solutions, AML solutions, reporting, compliance, and so on. And we are able to do it very quickly to run the whole bank. We are owned by the banks, so we are a non-profit company. So basically it means that all the solutions we deliver are for the banks to serve them, help them to meet European requirements, Danish requirements, and so on. Through that, we are currently supporting almost 30% of the Danish banking system. And what it means is that we support through the banks 30% of the business customers and around 22% of individual customers. So this is, let's say, the environment in which we are working as a company and we are supporting. We do it through around 1,700 skilled engineers, employees, and so on, who serve on a daily basis the customers to deliver the value. And our sole purpose is to be the leading fintech integrator for the Danish banks. What it means is that we have to be on the top of the game in terms of the solutions, in terms of the functionality, or anything new regulations that the European Union has came up with. And we have to make sure that those solutions are compliant. So that none of the banks which are using our solutions will get any penalties because of that. So this is a little bit the background as a baseline, so you will know what is our starting point on this journey of the tech transformation. So what I would like to do now is take you a little bit into the past, then focus a little bit on the present, and then move into the future as we are going to this tech transformation. So the past, the banking journey. I'm not sure if anyone is here on that who can remember, but until 1960s, this is how banking did look like. Everything was done in the notebooks, meaning every transaction, everything was noted, removed, and so on. And every single day when the banks were closing, there were cars, trucks with those data passing between the branches and the main offices to align. Right now it looks ancient, but that's how it was until the 1960s. Around 1966, we started to see a new IT solutions. You may see what it is, punch cards. So this is the initial way how the initial computers were programmed. But this has involved still a lot of errors, meaning like a human could make a hole in the wrong place, causing lots of grief for the banks, meaning nobody would like to see that suddenly their money have vanished from the account. If they would top up, everyone would be happy. So despite the machines were already kicking in into IT banking sector, still the books were being a parallel solution for a safekeeping. And then 1980 was really the year where the computers were said like, right, this is a reliable solution. The whole banking sector can live with it. And this is more or less the time, give or take, where the banking sector around the globe started to use the IT solutions going forward. So that's the journey of the banking from the IT perspective. Now, present today, do you know anyone knows what this is maybe, by any chance? It's not Skynet, but something different. Almost. It's an IBM mainframe. A little bit ancient, but around 1959, IBM started to work on the solutions, IT hardware, which solely was designed and created to support the banking sector, vast amounts of transactions, whether it was payments and so on. And ever since, they are evolving this solution. And if you're going to see, Mainframe from IBM is still supporting over 90% of the banking financial sector around the globe. Whether we like it or not, of course, if we're going to exclude some new startups, all the banks, all the institutions, they still run on the mainframe. We mostly use version Z13, but the latest one is Z16. And the sole purpose of those machines is really to support vast amounts of the transactions. You can see a little bit naked version of it, with the console, some heating, cooling equipment, etc. But the core situation there is this red box where it stores a massive amount of CPUs and RAM memory. Those are special processors designed by IBM to support the transactions and operations. So if anyone would like to play a VHMIN on it, this would be terrible equipment to do so. Your old laptop would be much better. But when it comes to calculations, operations, and transactions, it's like a super duper computer for that. And that's what we are using still today. And like I said, most of the financial institutions are still basing on that. Now, before I'm going to go into further, I got a question. Does anyone know who James Gosling is? Anyone? Raise a hand. Okay, couple of you. Awesome. So you will know where I'm going to. But I asked this question to my team. And funny enough, they said they don't know James Gosling, but they know who Ryan Gosling is. So I thought like, okay, 1-0 for a Hollywood guy versus IT guy. But then I asked them another question. What was so inventive and so on between years 1989 and 1991? And again, they managed to astonish me because they said Baywatch, David Hasselhoff, Pamela Anderson, and so on. This is not exactly where I wanted to end up, but then, that's the teams. But what has truly happened, and James in 1989 started to work on the Oak language at that time. He started to develop the language, which basically he saw a future in it. And then 2 years later, he changed this name, rebranded it as the language into Green. The purpose of this was he wanted his fridge to be able to talk to his toaster. So basically, already in the early 90s, he wanted to start to work on the Internet of Things and prepare for that. Despite the equipment was not fully ready, this was his purpose in terms of evolution of the language. While he was working on that, the key breakthrough came in 1995. And then he rebranded the name, and this is how Java was created. So he's the sole father of why we are here, why we are gathering here, why we are working on it. And funny enough, just a fun fact is that James loved coffee. That's the reason why in the Java logo you have a cup of coffee, because he was sitting with it, and that's how he designed what he branded as Java. So ever since, he's the guy who kind of, is behind all of this. And of course, we had a Java Standard Edition, Mobile Edition, Enterprise Edition. Now we go to Java version 23, 24, and so on. But that's how it's all started, basically. So let's come back now a little bit to something at the present. I'm not sure if you're aware of, but despite COBOL and the mainframe might be seen as an ancient technology, this technology is still ruling the world of the finances. But it is possible to run Java on the mainframe. IBM, despite is fully focused on developing mainframe technology in a COBOL language, they are as well supporting to run the Java. So over the last 20 years, it was possible to run Java virtual machines. It wasn't perfect. It is still not perfect, but it is doable. However, there are some certain limitations or the consequences. While there are new versions of the mainframe, IBM recognizes that Java is a technology that is powerful, and that's something that is not so old and it's the future. But the situation is that despite they make improvements in order to run Java much more quicker, with the better performance, efficiency, and so on, it's still not there yet because, for example, Java is running on the separate processors, not the same ones as a COBOL, with the lower frequencies and so on. Therefore, it puts the Java a little bit in the worse position that it is. And therefore, we can't really still achieve the results as they are. Nevertheless, in a company, we started to run the tests. What would it take and how would Java perform on the mainframe and whether this would be a viable solution? So where we started off, where every single coding starts, right? Hello world, in our case, hello mainframe. So we wrote this simple code, we compiled it, we logged in with the SSH client, used the shell commands to upload it to the mainframe, see whether it works. Yes, it did work. We just got hello mainframe thing. So then we moved into far more thorough tests where we started to compare Java with the COBOL. As you can see, we used the versus REST calls, we used to use unique IDs to see how Java would be able to handle transactions on the mainframe, how it would be able to basically perform. And until so far, unfortunately, it is not as good as COBOL, basically. So the way how we see Java, there is a great integration layer between, let's say, the old world, which is mainframe, and the new one. Maybe in future it's going to change. Maybe if things going to evolve. But right now, where it is, as it stands, COBOL on the mainframe is the one which still runs, but this is how it was designed. So Java is trying to kick the doors, but it's still not there. Nevertheless, we see it as a quite vital tool for the future because we see Java as, as a king of the backend. And hopefully at some point, it might be able that it's going to take a lot of functionality from the mainframe. And this is our idea how we want to do as part of the tech transformation. Now, what is a tech transformation BEC? You may have came across this in previous companies, jobs, wherever they are. Everything is changing. All the solutions have to evolve, right? And for us as a company, we did set ourselves those few pillars like cloud. Everything is going to the cloud, so we need it for us, for our customers, the data. Banking is very sensitive on the data, right? To a few digits after the comma. So we have to stay with our banks on top of that data. Unbundling the mainframe. This is the key which I want to focus on a little bit because, like I said, we are looking into how we can untangle the functionality from the mainframe. And this is where the Java is kicking in to help us out with it. API adoption. This is more of a, like putting an integration platform for us, again with Java. And then one as SDLC. This is something that we want to improve the way how we develop changes, deploy the changes, and making sure that we are doing them in the right time. And far and least is modern operations. We are in the very sensitive area where basically it has to be stable, reliable, and efficient. So those are the key things for us when we come to thinking about the tech transformation. Now, the future. The reason why we need to unbundle the mainframe is over the 60 years, we have discovered that we got over 84 integrations between the programs, between program and data B tables. DB2 tables is something like, a database, right, with the tables itself. But we came to this conclusion that it is astonishing how many interdependencies you have and how difficult it is to touch this monolith. Nevertheless, as a company, we decided to pick up the glove and make it happen. There are companies which are afraid, a lot of them, they are afraid to do that. There was a bank in Asia who made an attempt to remove mainframe. They were making preparations for over 2 years. And when the day came, they were out of the business for 5 days because everything went down. So it took them 5 days to restore the mainframe monolith. And then they said, we're not going to touch it for a long time. Here in the BEC, we are looking into to make this attempt. It's not a short and simple, let's say, game, but we have a plan then where we're going to try to do that. And where we want to end up is modularized mainframe, that we're going to exactly remove those interdependencies. And as you can see here in the middle, we're going to have this integration platform. And this is where the Java will be the key stone in all of this for us, because we want to make sure that everything will be running, and as much as possible, we will be removing from the mainframe. It is not a simple task. It's not a short task, but this is something where we want to get into in the longer term. And while this may sound a little bit simple, Java is really the key to all of this. This is a very short diagram, but this is an example of the real case. This is our plan for the next 5 to 7 years in order how to achieve that. While we are looking into all of this, it's just a simple thing that mainframe will be factorized into certain areas, and party, just for those who don't know, it's not a bunga party, but by party in financial sector, we mean the data which describe the customers, the account, the address, and so on and so forth. So the mainframe will still be holding the data, but the interface integration layer, this is where Kafka, Java will come in, and they're going to be the most important engine behind all of that. So we're going to use a REST API, mainframe API, Kafka events, and so on. And this is the journey where we're going to need all the Java power we have and need in order to make this happen. This is the plan for the next 5 to 7 years, like I said, but ultimately, we want to have a full flexibility how it's going to look like, so that in the future, the channels, the banks, or let's say the new applications will be able to call out those details, and we're not going to have a monolith structure like we have today. Now, can you work out what out of those two pictures, what it is? Like punch? Almost. Key takeaways, right? So every tech transformation is picking up the pace after a start and so on, but there are always the challenges. And you may have seen this, you might be stuck with some application with the Java version on, I don't know, version 8, 17, whatever. And we see this as well. So one of the first things is that we as a company, as a BEC Financial Technologies, we are, like I said, we are picking up the challenge, and we are trying to show the other companies how we are approaching this, how we are tackling the issues, and how we are making it happen. We see Java as a very important bridge between the old world and the new world, basically, like I said. And that's going to be a fundamental base for us to achieve all of that. Transformation is a process. It's not a demolition. So it doesn't mean we disable things, we switch off things tomorrow and then hope for the best. It's a stage where we have to case by case consider what is viable, what is reasonable, and what delivers the value. Because, for example, not always you have to use Camunda. You can easily use Spring, right, or a Chrome. But we've seen those sort of situations where, because of the ambition, somebody was using Camunda just as a scheduler, right? So all of that is being considered, how to do it, what to do it, and basically, what sort of pitch points it may get or bottlenecks in the future in order to make the right decisions. And then there is always a reason why not to do it. Somebody always going to come up, oh, that's too complicated, we don't have a knowledge, it's old version of Java, and so on and so forth. That's fair enough. But as long as you build the right mindset, and people around this, why we are doing this, why we want to achieve this, then you will see that the doors really open. And what I mean by this is that, the product line, the business, us as engineers, and so on. Because if you're going to have the right people on it, people will, instead of resistance, will start to look into the options, how we can achieve that, what is the viable thing to do. And not always you need a super duper people on it. You need the people with the right mindset who can try and fail even now and then, but still with those failures, they're going to learn and maybe discover something new. So that's how we approach those transformations. In terms of lessons learned, What we can see, and not only in BC, but in the other companies talking to them, is teams and domains responded to convey the law. Meaning you're going to have some areas we're going to see that everyone and nobody is responsible. And then, how to progress things. So it's quite important to have this sort of a mindset and the buy-in, which I said earlier. The monoliths are big. Like I showed you, we have those 84,000 iterations. But as we are 60 years old, you may see situations that some of those guys who built those are gone. They are retired, the knowledge has been passed on, etc. And it's quite hard to dig into it, etc. So when we are making the decisions, it has to be really considered carefully. Complexity. You may have systems which have 4,000 screens or more, right? And then over the time, the situation might be that some of those screens are a dead code and they are being basically still moved from one version to another, etc., without the revision. And this kind of puts another angle, how to transform. Should we transform? Should we move this? Or should we just disable it and remove that? And far the most biggest one is infrastructure capacity and the costs. Because number of the small servers is more expensive than one big one. Right, but everyone thinks, oh, we're going to build microservices, we're going to deploy 5 servers, and that's going to work. But then behind this are running costs like patching, maintenance, support, and all that stuff. So all of this has to be taken into account, and that's what we are kind of in some way breaking through. But but like I said before, we are making it happen, and that's what we are fighting with. So with this in mind, what do you think about that? I hope you were able to read the title. Amazon Prime Video made the step. They moved from the monolith to microservices. And then they realized they have made a huge mistake for them because they rushed into things. They jumped into the change without possible considerations. And then they reverted back to the monolith because it came out for them that operational costs of the volumes of read and write have kicked the cost so much that it was kind of overkilling their finances. And then by moving back to the monolith, they were able to cut the cost by 90%. So what I'm trying to say is that always when we make those changes, we always have to consider what are the values, not just rush things through. And that's what we are doing. And that's why our plan is for the next 5 to 7 years to make it reasonable. So with this in mind, just to finish off because of the time, if you already have any COBOL trauma because of what I have shown you about the mainframe, because of your companies or whatever, remember that you can always wrap COBOL with the Spring. And this is how we see the Java, that despite we have a mainframe, we're going to have a Java integrating everything for us. And that's going to be the strength of our change in the tech transformation. So thank you for listening. Thank you for the time. And that's that.